Alright, let's go with the next question of the day. So number 54, spiral matrix. Given an m by n matrix, return all elements of the matrix in spiral order. Okay. Interesting. Well, we can say if our what I'm thinking is that we start off with that size, then 3. So we start with traversing 4, traversing 3, then traversing 3, which is 4 minus 1, 2, technically, and then 2, or 3 here. Or actually, this will be interesting. Column traversal is equal to matrix dot size. Var row traversal is equal to matrix. We'll grab the first one, dot size, because it really doesn't matter, because the spiral, the m by n matrix should have a constant row size, so we just take the first one. Then we can say for call in 0 to column traversal minus 1, then we wanted, I see where this is, where this gets complicated. Okay, so we start by going through the row, or going through the columns, and then afterwards, then we do for row in matrix column traversal minus 1. So we start at we start at this last one, all the way to matrix at column traversal dot size minus 1. Let's see how that looks first. Matrix call row traverse. We'll start it at 0. Print matrix should be matrix dot size minus 1 row, and then we'll just return a blank list of integers, because I just want to see how this runs first. Hidden out of bounds exception. Oh, it looks like we start with the, so this, yeah, so that's the row first, but we want the column first. So realistically we want, so the first value is the row, row column border, just so we want to do 0 0 0 1 0 2. Then we want to do 0 1 2 1 2 2 2. So we want to start by doing row in that order. So matrix column traversal. Actually, we want to do call, but it's like that. Is it like that instead? Oh. So that should print 1, 2, and 3. Yep. Then we want to do, starting at that point, so we kind of want to save this call. Does this actually save call, or? Probably not, huh? Yeah. Could do that. Then in here, for our row, we want to start at 0, 1, 2 plus 1. Well, it's plus 1 now, but it's going to be minus 1 later. When going down, minus 1 when going up. Then we want to go down until there. Zero, 1, 2. How large? So each of those is a we start with it's a row. So how long is the row? Is this the right? Versal minus 1. And this is going to be call. Yeah, indices. Oh, let's rename it. Mm-hmm. It would be what is matrix of 0? Row traversal. It's 3. Isn't that fine though? 0, 1, 2? Print column row. Should be fine. I don't know why it's going to 3. Oh, it's the column. -1. Oh. Looks like that's not quite what we want. That just moved that there. Seven, 8, 9. Why is column? Oh, it's row then column. Whoops. Row, column, -1. Okay. But we want to start really at so column doesn't change. Or column traversal minus. It'd be then 2, 2 would be here. Then we kind of want to go backwards and go. This would be row 2, column 1, then 2, 0, then 1, 0, then finally 1, 1. Interesting. Ooh, this one might get me then. Right now what I'm thinking is that for our row and our column, we can probably keep track of it somehow in some sort of counter, and then slowly work on that. And so the idea is that we do one full cycle, which goes right, down, left, up, and then that counts as one cycle, and then we just keep on repeating that cycle So right, down, left, up is one cycle. Repeat until you reach some base condition. Though I'm not sure what that base condition is yet. Is it guaranteed that the spiral will be in order? If it is guaranteed that the spiral will be in order, no, it's not in the order that we expect. It's in some sort of order, but it's just not in the order we expect. I wonder if there's a mathematical ordering to it so that we just don't need to actually traverse through it in this case. That might be interesting. Let me think. So we can do this. So this is going right. It's going down. And after we finish this, we do the column traversal. So the column traversal starts off as 3. Then we decrease it to 2. Then we do for call in. We can say var current row. Maybe we do row traversal actually. And we want to do, well, 0, 1, 2. This is 2, 2. So we're starting at here in row traversal -1 down to 0. Well, down to 0? Maybe not down to 0. Because we'll bump into stuff later. But if we do this, we can do a print matrix. We want the same row. We just want to change the column. So 1, 2, 3. What is it called? Current row. Or sure. Row current row is row. So that brings us like that. Then column traversal minus minus again, print line again, and then for row in current row or column is equal to call. Column down to 0 again, maybe not 0. Print our matrix at our row at our current, or it's just called column, and row, our current row is row. Let's see how that looks. That'll probably overlap to our 1. Yeah. What is our column? Our column is correct because it printed out the correct value. It's just that our current row doesn't change. Column. Three, 6, 9. This is weird. Okay. It's printed 7, which means that the current row was 0, or the current row was 2, which is correct. The column, though, column is call. Okay, so that seems to have done the first cycle. So 1, 2, 3, 3, 6, 9, 9, 8, 7, and 7, 4, and 1. Now we just need to set the limits on how far we can go. So the column limit, we'll call these column limits, I think. That might make more sense. And var row limit up, down, left, column limit right. Actually, this is the column limit right. Column limit left is 0. You can say column limit right. This would be row limit down. This would be column limit left. And this would be row limit up. And this should be practically the same for now. Looks like we got an out of bounds exception for row in row limit down. Okay, we want to do a -1 there. We want to do a row plus it would be a +1 here, and here it would be a -1. In this column it would be a -1. And here it would be a column limit left +1. Row limit up +1. Column limit right -1. Row limit left -1. Or sorry, row limit down -1. Let's see. There's lots of moving parts here. 1, 2, 3, 3, 6, 9. Call limit right should be a left is right. Column limit right -1 should be fine. Is it the current row that's being messed up? Column limit right. Oh. What if we did row limit up? Right minus down. Yeah. We're kind of right back at where we started. Okay. I don't think I'm really getting really far into this. I think that this might work. We just need to tweak the settings a little bit more, but honestly, I'm not really sure exactly how to do this in a way that is fast, so I think I'm gonna start taking a look at the discussion tabs and see how others are doing this problem. Okay, so I've adapted some solution, and I was actually pretty close, all things considered, with my intuition, like going through sort of the edges and things like that, but I didn't really make the connection that sort of as you travel, like let's say you travel the top edge, you want to limit yourself so that you don't ever hit the top edge ever again, because that edge, that row at the top is done. Same thing if you go along the right edge here with the 3, 6, and 9, the 9, 8, and 7, with the bottom edge and the right edge here, and then also the left edge when you go to 7 and 4. So that's basically the solution. So while we have sort of more rows to traverse, we'll start by always traversing. Our cycle will start by traversing along the top edge of our spiral. So 1, 2, and 3. And then we will stop ourselves from going on that edge ever again by incrementing the top end. Basically, this counts as like a sort of limit to sort of an inclusive limit on where we can traverse in the future. We do the same thing for the right side, the bottom, and then the left. And then we repeat this cycle until we don't have any more edges which we have not traversed yet. In addition to that, we also need to throw in an additional check in the middle here after we have traversed the top and right edges. The reason why we do that is because when we travel on the right or on the top, along the top or the right edges, then we don't actually check for the additional condition for the edge condition, or the I guess we could call it the base condition. For the left end less than equal to right end, top end less than equal to bottom end, until we finish the entire cycle. But there's a problem to that because of the fact that we may actually run into issues regarding uneven or non-square matrices. So for example 2, we go through here, the top edge is done. We go through here, the right edge is done. We go through here, the bottom edge is done. And we go through here, the left edge is done. When we go through this again, the top edge is done, but the left and right edges are still not quite where we want them to be. This ends up creating an issue where we actually go back and we traverse up, and we actually encounter this value again before we terminate. This is prevented if we do an additional check here to make sure that we don't run into our same edge again after we finish traversing our matrix on the top and right edges. Again, we don't do this for traversing the bottom and left edges because naturally by the time that we finish this half essentially of the cycle, we will run this while loop check. So we don't need an additional check on that half of our cycle. This naturally traverses all elements within our matrix, and so it runs in O of m times n time. Additionally, if you count the output array, then it will take O of m by n space, but since usually we don't count the output as part of our algorithm space complexity because it is our output and not just some intermediary data structure, then in that case we really take constant space. Let's go ahead and run this again. I ran this once just for a sanity check, and you can see that it's a pretty standard, pretty normal runtime. But in any case, I hope you learned something, and I'll see you for the next problem.